Hello everyone, myself Assistant Professor Milan Patel. am Electrical Power System from the Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today we will discuss about the chapter number 2, Power Frequency Disturbance, from the subject Power Quality and Management, having a subject code of 2180911 from the 8th semester of the Electrical Engineering Department. So now flow of contents for today's video lecture is voltage tolerance criteria. So this is the most IMP topic, and this is the GTU question which was asked in chapter from the chapter 2, power frequency disturbance, and it has a weightage of 10 percentage, and uh, we will cover today question number 6. Question number 6. Explain voltage tolerance criteria with suitable example, which was asked in winter 17 and most IMP question. So now, of voltage tolerance criteria. This question may be asked for 7 marks in GTU. It was asked many times in previous GTU examination. So, first of all, manufacturers of computers and data processing equipment do not generally publish data informing the user of the voltage tolerance limit for their equipment. So, an agency known as the Information Technology Industry Council (ITIC) has published a graph that provides guidelines as to the voltage tolerance limits within which IT equipment should function satisfactorily. So, the agency Information Technology Industry Council (ITIC) has published the guidelines for the voltage tolerance limit for the IT equipments. IT equipments means the equipments used in information technology for functioning satisfactorily in a particular region. So, ITIC give the graph for ITIC curve in the year of 2000, and this is the graph for the particular IT equipment. The graph is the percentage of the nominal voltage versus the duration of the time in cycle in cycle or cycle or second. So y axis પર નોમિનલ વોલ્ટેજના પરસન્ટેજ આપ્યા છે અને x axis પર ટાઈમ ડ્યુરેશન આપ્યો છે અને એ સેકન્ડ અને સાયકલ બેવ પેરામીટરમાં આપેલો છે. ઓકે, સો this is the 0, 12, 25, 40, 50, 70, 80, 100, 120, 140, 200, 300, 400 and 500. So draw all these parallel lines for this particular voltage, nominal voltage percentage limits, and after it we have to give duration for this particular equipment function. So we have to start from 0, and first one is 1 microsecond, then 0.001 cycle, after it 0.01 cycle, then 1 millisecond, 3 millisecond, 20 millisecond or 1 cycle, after it 10 cycle, and then 0.5 second, 100 cycle, 10 cycle. So this is the graph given by the ITIC curve. So we have to consider all these parameters as given in this graph. So again draw these vertical lines at all these particular cycles or the time period given here. So by connecting this all these horizontal and vertical lines, we have start from 0.01 cycle, 0.01 cycle with 500% of nominal voltage. Take one point, then second point is at 200% of nominal voltage with 1 millisecond, then 140 second, sorry 140 percentage, then 120 percentage at 3 millisecond. So we have to take all these points as shown in figure. You have to remember this all the points and then connect all these points like this. Okay, so by connecting this all these point, we can see three regions in this graph. Three regions in this graph. First one is above the first line, this portion. So this is the prohibited region. This is the prohibited region in which the IT equipment must not be function. આ રિજિયનમાં આઈટી ઇક્વિપમેન્ટ ફંક્શન થવું જોઈએ નહીં, નહીં તો તે ડેમેજ થઈ શકે કે કોઈ પણ પ્રોબ્લેમ ક્રિએટ થઈ શકે અથવા તો તમારા ડેટા કરપ્ટ થઈ શકે. So this is the prohibited region for the IT equipment. Now other one is the region between this upper line and lower graph. So this is the no interruption in function region. Voltage tolerance envelope. This is called voltage tolerance envelope, and this particular region is called no interruption in function region. આ રિજિયનમાં તમારું ઇક્વિપમેન્ટ પરફેક્ટલી ઓપરેશન અથવા તો ફંક્શન કરશે. સો ફોર સેટિસ્ફેક્ટરી ફંક્શન ઓફ IT equipment, we have to run it in this particular region. And last region is no damage region. It is a region below this graph, below this graph. So this is no damage region. So this is the region in which the equipment will function but not satisfactorily. આ રિજિયનમાં તમારું ઇક્વિપમેન્ટ આઈટી ઇક્વિપમેન્ટ ફંક્શન કરશે પણ તમારા જરૂરિયાત મુજબ એ તમને આઉટપુટ આપશે નહીં. અને બીજી એક વાત, એ ડેમેજ પણ નહીં થશે. That's why it is called no damage region. So again discuss about this figure. In this figure, y-axis represent the voltage as a percentage of the nominal voltage and x-axis is the time duration in seconds or cycle. So the graph contains three regions. First one is the area within the graph is the voltage tolerance envelope in which equipment should operate satisfactorily. So the graph between the area within the graph is called voltage tolerance envelope in which the equipment should operate satisfactorily. And the area above the graph is the prohibited region in which equipment damage might result. So બીજો એરિયા છે જે ગ્રાફની ઉપરનો એરિયા છે તેમાં ઇક્વિપમેન્ટ ડેમેજ થઈ શકે છે. Third one is the area below the graph is the region where the equipment might not function satisfactorily but no damage to the equipment should result. So these three regions are main in this voltage tolerance criteria. So the several types of events fall within the regions bounded by the ITIC graph as described below. So first one is steady state tolerance. The steady state range describes an RMS voltage that is either slowly varying or is constant. Range is plus or minus 10% from the nominal voltage. So the steady state tolerance voltage limit is plus or minus 10% from the nominal voltage. Line voltage swell. This region describes a voltage swell having an RMS amplitude up to 120% of nominal voltage for up to 0.5 second. So this is for RMS amplitude increase for 120% of the particular RMS value for the particular time of 0.5 second. So this is the line voltage swell. Next one is low frequency decaying ring wave. So this region describes a decaying ring wave transient that typically result from the connection of the power factor connection capacitor to an AC distribution system. Next one is high frequency impulse ring wave. This region describes the transients that typically occurs as the result of lightning strike. Lightning strike. So this is the for the lightning strike. Now, next one is voltage sag. So two different RMS voltage sag are described generally the transient result from application of heavy loads as well as fault condition at various points in the AC power distribution system. Sags to 80% of nominals are assumed to have a typical duration of up to 10 seconds and sags to 70% are for up to 0.5 seconds. A condition considered as a voltage sag for the particular voltage RMS voltage decrease. So 80% for the 10 second and 70% for the 0.5 second. Now dropout. Voltage dropout includes both severe RMS voltage sags and complete interruption of the applied voltage followed by immediate reapplication of the nominal voltage. So it lasts up to 20 millisecond. 20 millisecond. Dropout. Dropout means complete blackout of the voltage or complete cutoff of the voltage or severe RMS sag for the 20 millisecond for the 20 millisecond. Now, no damage region. Events in this region include sags and dropouts that are more severe than those specified in the preceding paragraphs and continuously applied voltage that are less than the lower limit of the steady state tolerance range. A normal function state of IT equipment is not expected during these conditions, but no damage to equipment should result. So in this region, no a normal functional state of uh, IT equipment is not expected, but during this condition, no damage of the equipment should result. Third one is prohibited region. This region includes any surge or swell which exceed the upper limit of the envelope, and in this region, IT equipment might damage. So this is the region includes any surge or swell which exceed the upper limit of the envelope, and in this region the equipment might be damaged. So this is the theory for the voltage tolerance criteria. Most IMP for the exam point of view, and it may be asked for the 7 marks. Thank you.